All right, let's get into it. Today, we're going to peel back the layers of what I like to call the React onion. We're going to start right at the very core, how this thing actually works, and then build our way all the way up to crafting some seriously high-performance, pro-level apps.
And we're going to kick things off with the question that, let's be honest, every single one of us is asked at some point. You build a new app, right? At first, it's super snappy, everything feels great. But then, over time, it just gets sluggish. Clicks feel delayed, animations start to stutter, and you're just sitting there scratching your head wondering, what went wrong? I bet that sounds familiar.
Well, the answer to that big question, it starts right here, with the very first layer of our onion. We need to understand what React is really doing under the hood, every single time it decides to render something to the screen.
Okay, so right at the heart of React, you've got this thing called the virtual DOM. The best way to think about it is like a blueprint. It's this super lightweight copy of the real browser DOM, and it just lives in memory as a bunch of JavaScript objects. Now, why does this matter so much? Well, because touching the real DOM directly, that's slow. It's expensive for the browser. But changing a simple JavaScript object, that's lightning fast.
So here's what happens. Your state changes, right? React immediately creates a new virtual DOM tree, and then plays a game of spot the difference with the old one. This whole process is called reconciliation, and React is pretty smart about it. It follows a few simple rules to stay fast. First, if an element type totally changes, like a div becomes a span, React doesn't even bother comparing it. It just throws out the old tree branch and builds a new one. Easy. If the element type is the same, it just glances at the props to see what's different. And then there are lists. Oh man, for lists, that key prop is your absolute best friend. It tells React, hey, this item is the same one as before, it just moved. This keeps it from inefficiently re-rendering the whole dang list. And this whole process has changed a lot. Back in the day, before React 16, rendering was this big, clunky, all-or-nothing job. It would start, block everything else, and you just had to wait for it to finish. Super slow, totally unyielding. But then came the fiber architecture. And this was a game changer. It made rendering asynchronous and, get this, interruptible. This means React can be in the middle of a huge, heavy rendering task, and if you click a button, it can actually pause what it's doing, handle your click, and then pick right back up where it left off. That right there? That's the magic behind why modern React feels so incredibly responsive.
But, even with this brilliant system, things can still go sideways. And that brings us to the next layer of our onion, memory leaks. I like to call them the silent performance killers, because they are very often the real culprit behind that sluggishness we were just talking about.
And the symptoms? They're probably exactly what you're picturing. The longer you keep the app open, the slower and slower it gets. Scrolling gets janky, animations start to lag, and then you open your task manager and see that one browser tab is just gobbling up a massive amount of RAM. Yep, those are the big red flags.
So you might be asking, how does a leak like this even happen? Well, here's a super classic example. You have a component, and when it mounts, you use a useEffect hook to, say, add an event listener to the main window object. Simple enough. But here's the catch. What happens when that component unmounts? What happens to that listener? Absolutely nothing. It just sits there, dangling in memory, still holding on to a reference to your old unmounted component. And because of that reference, the garbage collector can never clean it up.
Thankfully, the fix is just beautifully simple. The useEffect hook has this built-in feature where you can return a function. And that function, that's your cleanup crew. It runs automatically right when the component is about to unmount, and its one and only job is to remove that event listener you added. And boom, just like that, the leak is plugged. The reference gets cut, and JavaScript's garbage collector can finally swoop in, do its job, and free up all that memory.
All right, so we've just plugged a leak on the client side. That's great. But modern React is starting to ask a much bigger, more fundamental question. Does this component even need to be on the client in the first place? And that question brings us to our next big layer, a huge shift in how we think about architecture, server versus client components.
So get this, in modern frameworks like Next.js, components are actually server-first by default now. That means their code runs on the server, renders to HTML, and the JavaScript for it never even gets sent to the browser. So you're probably thinking, wait, how do I get any interactivity? How do I use useState? Well, you create a boundary. You use this one simple little directive at the top of your file, useClient. That's it. That's your signal to React that says, hey, this component and anything it imports, this stuff needs to run in the browser.
And this table really breaks down the trade-offs perfectly, right? Server components, they live only on the server. That means no stateful hooks like useState or uEffect, but the upside is huge. They add 0 kilobytes to your JavaScript bundle, and they can talk directly to your database. Then you have client components. They give us all the interactive goodness we know and love, all the hooks, all the state, but their code has to be downloaded and run by the browser. So the real art of modern React development is knowing when to use which and trying to keep as much as possible on the server to make your app incredibly lean and fast. Okay, so we've got this incredibly powerful new architecture at our fingertips. But you know what they say, with great power comes, well, a lot of complexity. So how do we manage all this? How do we build stuff and actually feel confident about it? That brings us to the very last layer of our onion. And this one isn't a piece of tech, it's a mindset. And this is where we bring in the whole philosophy of test-driven development, or TDD for short. The goal here is really simple. Find your problems early, fix them fast, and, most importantly, be able to code with a real sense of confidence instead of that nagging feeling of uncertainty. The whole process really boils down to the simple, repeatable little cycle. First, red. You write a test that you know is going to fail, because, hey, you haven't written the code for it yet. Then, green. You write the absolute bare minimum code you need to make that test pass. No more, no less. And finally, you repeat the cycle by refactoring, cleaning up your code, and then writing the very next failing test. It's this really tight, super satisfying feedback loop.
And I think this quote just perfectly captures the why behind TDD. It says, test-driven development is the art of minimizing that uncertainty, allowing you to feel confident about your code from the moment you write it. See, it's about so much more than just catching bugs. It's really about changing the whole feeling of development, making it more predictable and, honestly, a lot more enjoyable.
So, let's wrap this all up. Let's put our onion back together. Building truly great, performant React apps, it's a holistic thing. It really is. It starts deep down with understanding the core engine. That's reconciliation and fiber. Then, it's about being disciplined on the client side, preventing nasty stuff like memory leaks. From there, it's about leveraging the cutting-edge architecture, like server components, so you can ship way less JavaScript. And what holds it all together? A solid, robust workflow, like test-driven development.
And that leaves us with just one final question for you to think about. Now that we've peeled back all of these layers from the very core of React all the way up to your personal workflow, what's the one thing you're going to change in your own code tomorrow?